Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. Whether you're targeting a grade 7 or pushing for a 9. Let's get into it.
Hook. This one type of question lost more marks than any other on last year's higher papers, and it's actually easy when you know the trick. Imagine two lines in an exam script, one where a student writes x to the power of a half times x to the power of a third divided by x to the power of minus a sixth and leaves it as a messy fraction of powers, and another where a student calmly converts to fractional indices, adds them, and writes the final answer, x. That calm student picked up full marks. Today I'll show you the simple rule that turns the messy script into marks on the page.
Section 1. The concept. Start with the basic idea. A root is just a fractional power. When you see the nth root of x, we write it as n root x. You can also write it as x to the power 1 over n, x to the power 1 over n. Why does this work? Because if x to the power 1 over n is the number that, when raised to the nth power, gives x, then x to the power 1 over n to the power n equals x to the power 1 over n times n equals x. So the notation n root x and x to the power 1 over n are saying the same thing in two languages. Keep that translation in your head. Roots equals fractional powers.
Build on that with the index laws you already know. X to the a times x to the b equals x to the a plus b. X to the a divided by x to the b equals x to the a minus b. X to the a all to the b equals x to the ab. If the exponents are fractions, the rules still work exactly the same way. So converting every root to x to something makes the algebra simple. You add and subtract fractions instead of manipulating roots directly. Let me show you a single worked example that uses those laws and stays neat the whole way.
Worked example, Part A. Simplify x to the power of a half multiplied by x to the power of a third divided by x to the power of minus a half. First step, rewrite everything as powers. They're already in fractional power form here. Now use the rule. Multiply means add, divide means subtract. So exponent total equals a half plus a third minus a half. Calculate with a common denominator of 6. A half equals 3/6, a third equals 2/6, and minus a half is plus a half. Add them. 3/6 plus 2/6 plus 1/6 equals 6/6 equals 1. So the whole expression simplifies to x to the 1, which is just x. That step, converting to fractional powers and working with common denominators, is the whole trick.
Worked example Part B. Rationalize the denominator. Write the answer for 5 divided by root x without a surd in the denominator. Rewrite root x as x to the power of a half, then multiply numerator and denominator by x to the power of a half. So 5 divided by x to the power of a half multiplied by x to the power of a half divided by x to the power of a half gives 5x to the power of a half divided by x. We usually prefer to write the numerator as a root, so that is 5 root x over x. Simple, complete, and no surd in the denominator. That's all rationalization asks for. Remove the root from the bottom. Section 2. Exam technique. Here's where the marks live. For Part A, an examiner typically awards 3 marks. M1 for rewriting the expression using indices or showing the intent to use index laws. M1 for the correct addition, subtraction of exponents, showing your arithmetic with common denominators. And A1 for the final simplified answer, x. For Part B, rationalization, expect M1 for showing the multiplication by the correct conjugate or power to remove the root, and A1 for the simplified final form. Always write the intermediate exponent arithmetic. That method line often earns a mark, even if you slip the final simplification.
Common slips that lose marks: forgetting to change division into subtraction of indices, mishandling negative indices by not turning them into reciprocals, and leaving a root in the denominator. A frequent arithmetic mistake is failing to use a common denominator when adding fractional powers. Examiners look for that step. If your final answer still has a negative index and the question asked for positive indices, you might lose accuracy marks. So always write x to the power minus 3 over 2 equals 1 over x to the power 3 over 2 if you need positive powers.
Section 3. Quick win and extension. Quick win, the 2-second check. After you simplify using fractional indices, raise both sides to the least common multiple of the denominators to check your work. For the Part A example, the denominators were 2, 3 and 6. The LCM is 6. If you raise both sides to the 6th power, any fractional exponents become integers and you can check equality quickly. Memory phrase, roots are powers. Clear the fractions by powering up. That test catches sign errors and missed fractions in seconds.
Stretch practice for a grade 9. Simplify and rationalize the denominator of cube root of x to the 5 divided by x to the half. Hint, write cube root of x to the 5 as x to the 5/3. Then subtract the exponent in the denominator using common denominators, 5/3 minus 1/6, and simplify. For rationalizing, if you end up with a denominator x to the a over b, multiply top and bottom by x to something so the bottom becomes an integer power of x. Examiners look for the fractional arithmetic shown clearly and the final expression with positive indices and no surd in the denominator.
Let that sink in. Convert roots to fractional powers, use index laws to add and subtract with common denominators, and use the power check to catch errors instantly. That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and printable practice questions at jcacademyonline.co.uk. Visit the site for step-by-step written solutions that match everything we discussed. Stay curious.
That's your quick win for today. If you want 50 worked solutions covering every topic we discuss on this show, check the link in the show notes. Until next time, trust the process and nail that exam. Stay curious.